So this is going to be the recording for 7.4 special parallelograms. So all the shapes we talk about here, just keep in mind that they will still be a parallelogram. So all of the parallelogram theorems are still relevant. I'm going to keep a note for that, and I think you guys should write it down too. So basically right here, if you see that I have a little copy, I want you to copy it down. Okay, I think there's only one thing that I don't need you to copy down, but I just put it there just in case for you guys. So the note was all these, all these new shapes are still parallelograms. That means you can still use those old parallelogram theorems, okay? Let me just put the old theorems. Okay, so just keep that in mind. The first one we'll talk about is a rectangle. You guys should know this one. All four sides have, there's four right angles, right? And then the opposite sides are going to be congruent. Okay, that's the main trait. So these two have to be congruent, and these two right here are congruent. That's all. But you got to make sure that there are four right angles in this thing. Okay, so that goes on to the next one, which is a square. Square is basically a rectangle, right? But for a square, all of the sides have to be congruent with the four right angles. Okay, and for the definition, copy it down just in case, because a lot of times when you do a problem, you need to go back and look at this definition, even though you think you know it. There are like these two facts right here. Okay, because there are going to be some questions where they ask you, oh, is a square a rectangle? The answer should be yes. And then, is a square a rhombus? That the response to that is also yes. Okay, but there's like very specific minor details right there that I underlined at the end. So if you guys ever need to like pause this video to copy something down, just pause and then copy down, then continue on with the video. Okay. It's just definitions at the very beginning. All right, so this is the last one. It's going to be a rhombus, and then plural is rhombuses, which sounds weird, but basically a rhombus here, it look like a diamond. People usually call it a diamond. It's a diamond looking shape, but the main trait is it has all congruent sides. But then if you notice, the difference between a rhombus and a square is that there are no right angles here. Okay, in a square, you see all the right angles, right? But for a rhombus, no right angles. But there are still the four congruent sides. Okay? So then we go into these two questions. Can a square be a rhombus? I think we already answered that. Yes? Yes, because a square has four congruent sides. So if you see my argument that I'm making here, I'm picking on the fact that a rhombus has four congruent sides, right? Okay, so your base is you're working with a square. They tell you it's a square. So whatever they tell you, go back and look at the definition. Okay, the square has four congruent sides, four right angles, and as long as you have four congruent sides, it is also classified as a rhombus. Okay, but then question two, you flip it around, right? Can a rhombus be a square? Your answer, it feels like yes and no. It would be no, but then sometimes there's the option to say sometimes, and this is the time where we can say sometimes. Okay, so you'll say sometimes. Say sometimes, but only if the rhombus has four right angles. Okay, well, let's say four right angles at the vertices. Okay, when I say the word vertices, I'm referring to like the points, right? So vertices are all the letters where they are. Okay. Okay, we move on. So over here, here's an example. There will be theorems, right? There will be theorems that we're gonna use and corollaries. So at this time, you should, get out your theorem sheet. It should be like on the third page over. 3, 4. The fourth page. Fourth page. Okay, it'll say corollaries. You'll see all the three shapes again. So we should be looking at the rhombus corollary over here. These directions, they're gonna be the same directions that you're gonna have in your homework. So I would copy it down and then listen very carefully to how I do this. Okay, so for the example, they tell you it's a rhombus and it is called QRST. The way I'm gonna draw the rhombus is I'll draw a rhombus. Okay, so you can just draw anything like this. Okay, so it looks like it. I'm gonna make it a rhombus. So a rhombus has all congruent sides. Okay, but then the way I label it is I'm gonna look over here. So I'm gonna look at QRST, and you have to go in order that they tell you. So I gotta label my my points in order. So I gotta go Q, R, S, T. So you saw I went clockwise. You can go counterclockwise if you really want to, but I stick to clockwise because I don't know, it just looks better. Okay, but then once you do that, you can refer to your drawing for every other problem. Okay, and you're just deciding between these two things. So you're either answering always or sometimes. Okay, so take a look at the corollary. Look at corollary 7.2. So I'll make that note just in case. Corollary 7.2. Okay, right here it says is angle Q going to be congruent to angle S? And your response should be yes. Okay, because even though they tell you it's a rhombus, right? A rhombus is still a parallelogram. Okay, so opposite angles will be congruent. Okay, so you'll say always, always, and then you'll just say your reason, because opposite angles and you can call it a rhombus, and a rhombus is always, or are always congruent. Okay, so that's the first example. You can draw it yourself, and then I will draw the same picture because I have a second example. Okay, so I'm gonna draw the same thing, and this time they're asking you to look at two different angles. Okay, this one came out worse, but doesn't really matter too much. All right, as long as you have these. Okay. If you take a look here, I gave you a little hint, but I think it's kind of I don't know, it's a little relevant. Okay, so right here, if you take a look at angle Q, because they're telling us to look at angle Q and R, is it always or sometimes going to be congruent? Okay, you don't have the option to say no, because technically your rhombus can still be a square. Okay, and in squares, if I go to a square, right, all of the angles are congruent to each other. Okay, so over here, you're gonna say sometimes, not always. Okay, so sometimes, because the rhombus can have 4 right angles, which makes all the angles congruent to each other. Okay, so in these problems, they're not forcing you to work strictly with like pictures like this, right? You just have to try to consider all the possibilities that a rhombus can be. Okay, so the first one is a rhombus can look like what I drew for you, but it can also look like a square. Okay, because a rhombus can be a square, so it could look like this, QRST, and you know, the defining part is all the sides are the same. Okay, but also if it were a square, then there would be your 4 right angles. Okay, which makes Q and R congruent to each other. But then if we also go back, I'll also go back to the first one, right? We could use the same square argument here and it'll still be true, because if you take a look at angle Q and angle S, they're still going to be congruent to each other. Okay, so all the possibilities, try to consider them. For rhombus, there's only 2. So rhombus can be like a straight up rhombus with no right angles, or a rhombus can be a square with all right angles. Okay, so those are the 2 that could be like the most confusing, and then it will be like a square and a rectangle. Okay, but I think the square and the rectangle argument seems more straightforward. Okay. Okay. This third one, they're gonna ask you to just name the quadrilateral. Over here, it should be quite obvious. Okay. If we do look at the corollaries, so corollary 7.2, okay, I can see that this quadrilateral has 4 of the same sides, okay, and it has to be all the same for this to be called a rhombus. Okay, so this is called a rhombus. You can just write the word rhombus. Okay, nothing too fancy. All right, so you have that, and you also have the angles, which makes this a parallelogram, but you really need to know that it's a parallelogram. As long as all 4 sides are the same and it's a quadrilateral, you can call this a rhombus. Okay, here's a fourth one. All right, so there's going to be some problems like this in your homework. We just got to find the measures of all the angles in this rhombus. Okay, there should be a theorem for you guys. I'll point to the theorem. So look at theorems. Look at theorem 711 and 712. Okay, they'll help you out here. Let me just space these out a little bit more so I can like explain. So I'll look at angle 1 first. So measure angle 1, and if we're gonna look at theorem 7.11, okay, and if you look at the picture that's there, you see that all the angles towards the middle, so all the angles like right here, they're going to be perpendicular to each other. So that means every single angle in here that I'm circling, those are all 90 degrees. Okay, so measure angle 1, that's 90 degrees. And then just say by theorem 711, okay, and then we're gonna go ahead and take a look at the rest. So the rest, we'll go in order. We'll go with measure angle 2. Okay. If you take a look at the theorem sheet again, this time I'm going to look at theorem 7.12. Okay. If you look at all those markings, right, they tell you which angles are congruent to each other. So right here, if I take a look at these two, okay, since I see that one of them is already 61 degrees, right, all of those angles individually have to be 61 degrees. Okay, if you guys remember perpendicular bisector, that is why this theorem for rhombus works. Okay, because the middles, as we talked about before, is perpendicular. So there exists a perpendicular bisector. So that means all these angles, like on the sides, right? All these angles on the sides, in my red circles and in my green circles, they're being split in half. Okay. So that means over here in the red, measure angle 2 is going to be 61 degrees by theorem 7.12. And that also means measure angle 3 is the same thing. Okay, so measure angle 3 is also 61 degrees by the same theorem. Okay, so there's that. Then lastly, we got to go look at measure angle 4. Okay, so measure angle 4 is going to be a little bit different in the way we find it, because well, if you take a look, right, there's nothing here for me to ever like reference or copy because there's no angles given over there. So we have to use what we know about a triangle, okay? Because if I draw it right here, okay, I'm just gonna separate that one piece, right? So basically what I'm doing is I'm taking this little triangle right here and I'm just drawing it on the side. All right. What I had was angle 3, angle 1, and angle 4. But I knew, or I figured out by theorem 7.11 that measure angle 1 is 90 degrees. So what I'm gonna do, I'm just gonna draw like a little box there, so I know that. And then measure angle 3 is gonna be 61 degrees, so I'll write that in. Okay. And that means you use what you know about a triangle, right? So properties of a triangle, all the angles in a triangle add up to 180. So you'll do 61 degrees plus 90 plus, you can call it measure angle 4. So you go to 180. Okay, and if you do all that work, you should end up that measure angle 4 is going to be 29 degrees. Okay. Okay, so maybe let me move that over. And that's how you find measure angle 4. If you notice that I'm not putting a theorem, it's because I didn't really use a theorem. I just used the properties of a triangle. Okay, all the angles add up to 180 degrees. Okay. Okay. So that's that. You should see it in your homework as well. But of course, if you guys do have questions, send me an email. I'll try to respond to it. Okay, or maybe I'll just drop the Discord so I can just talk to you guys and respond to you guys. Okay, so there's that. All right. So this is one of the theorems that I did write down because I think I wanted everybody to like look at it for problems. But don't copy down. You have it in your theorem sheet. It should be at the bottom of the sheet that we are currently on. It should be like page 5. Okay, second to last page. So if you take a look at it, so in a rectangle, right, and you take a look at the diagonals in a rectangle, they are congruent to each other. Okay, excuse me, this is the very specific case that I mentioned before in class about a parallelogram, that this is the only time, and in a square, that the diagonals are congruent or equal to each other. Okay, so it has to be a rectangle, it has to be a square. All right, so we're gonna take that theorem and we're gonna apply it over here. So these examples, yes, continue the notes, yes, copy it down. I'm gonna, like, if you need to pause again just to copy something down before I start talking again, just pause and we'll get through this. Okay, so let's do this one. So they tell you AC is 7x minus 15. Okay, so I'll just write it down. I'll write it down like this. Okay, so it might be a little messy. This is 7x minus 15. Okay, and then for BD, I'll do it like this. Okay, for me, the colors will help you guys out, but maybe try to use like different color pens or something. Okay, so it'll be 2x plus 25. Okay, but I mean, you don't even really need to write it in because we're gonna use this theorem. the diagonals will be congruent to each other. Okay, maybe make a note so it'll be easier for you guys. So note and write this one down. Note, you can set the diagonals in a square or rectangle to be equal to each other. Okay, so this note will carry you through some of the problems towards the end of our homework, and we're gonna do it. So we'll set them equal to each other. So AC is equal to BD. You can say, but like Pythagorean 7.13, the bell might ring, so you might hear that. It's going to be 7x minus 15 is equal to 2x plus 25. Over here, we go through same old stuff. Okay, so subtract 2x, add the 15 over to the right. Okay, you'll have 5x is equal to 40. Then divide that 5. Get x is equal to 8. Okay, and I think we just find x. Well, we found x, but if they ask you for whatever AC and BD are, you know already by now that you can just plug in x and find the value. Okay. Okay. Over here, does this have to be a rectangle? With whatever's given to you, it's drawn like that. Does it have to be a rectangle? I'm just pausing to see if you got something. But the answer is no. Not necessarily. Because I don't know anything about the angles, right? They didn't draw in the red square, right? So there's no right angles. So not necessarily, because there are no right angles. You can't say that it is for sure a rectangle. Okay, yeah, they have opposite sides being congruent to each other. Okay, yeah, it looks like a rectangle, but if they don't draw in the squares, or even one of them, just one of them, then you can't say for sure. You can't say for sure that this is a rectangle. Okay. Okay, I think we're done. This is your homework. This will be posted in the Google Doc that I have running. And this video should also be posted by Thursday when you wake up. Okay? If you guys have any questions, email me, and I'll probably drop my Discord on Classroom. Okay?